Here we are, another episode of our series of internal software design reviews. This is hopefully the last stop for our proof system for the next version of Wolfram Language. And let's start off looking at some graphic design for proof objects, I think. So let's see, where are we at here? So let's look at what are we looking at here? We're looking at your...
Yes. So, well, Chris, can you explain?
What is that?
Yeah, I actually thought we were going to open with the colors, but the first thing we're going to look at here is the summary boxes for these. This is my attempt. If we have a very, very complex network, like I'm thinking...
Right. Okay, that one looks nice. But it shouldn't say graph. It'll just say proof object, right?
Yeah, I was going off an older source notebook that is not for production, yeah.
So what's happening? If the thing is really complicated, it's going to this, but if it isn't so complicated, it's going to give it explicitly? Is that the idea? That seems kind of weird. I don't understand that. I don't think that's something we should do, because otherwise, how do you get to the explicit graph? Okay.
So I think here this was an exploration of colors, perhaps. There is another one with labels as well.
Okay, but let's take a look at what's an example here. This is, I mean, what we have, if we say find equational proof over here. Okay, so this is the old style. I don't know what this is. This is a graph plot with its old brown thing, right? So you're proposing a different thing with colors for that. Do we have the code to do that? Do you understand my question? So
I'm unsure if we have the code for that.
Okay, so what is that? Is that intended to be a graph object, or it's an output from graph plot, or what is it? How do we get to that?
I am actually unsure technically currently how we are generating the current iconizers, because...
Okay, so Jonathan, maybe you can say, what is this?
Well, in the implementation that I have, it's just a graph that we're displaying in a summary box.
Okay, well, fine. So this will be the same thing, except that it's a graph with colored nodes. Right. So I don't think there's a problem with that. I think it's just using the same graph rendering technology. It just is taking the color that's happening for the, I mean, so here, if you say this thing and you say proof network, if I'm not mistaken, then this would be that, right? And you're suggesting using those colors right here, which seems completely sensible to me.
Yes, I was just wondering, if we get past a certain level of complexity, these little summary boxes get awfully dense and noodly. I don't know from an aesthetic standpoint.
It's okay. It's okay. I mean, it's a complicated thing, and let's show that it's complicated.
Okay.
Well, what we typically do with summary boxes is that when they get very complicated, the problem is that they might take very long to typeset. So what we do is to have in some generic, typically in gray case. And
I mean, if we think that's going to happen at some point, well, when do we think that's going to happen? Above 100 nodes or what? And also, do we think that the right way to say what's going on is just, I mean, it's not a graph. It will say proof object here, right? So we don't really want to say vertex count. What do we want to say? Where did this come from, the vertex count and edge count? That doesn't seem right.
That came from an older version of
the... so it's irrelevant. So what we're actually putting up is this here. Is that correct?
So our plan, we were discussing this with Itai recently. He suggested that we have in the first line logic and number of steps, and in the second one, the theorem. And then the actions would be in the opened version, clicking the plus.
Why are we giving logic there? I mean, I guess, okay, but then are we giving it as an actual English words, equational space logic, or what?
Right now we are using the full string.
Okay, fine, but then are you proposing to combine those first two lines? That doesn't seem sensible. This seems like about the right size. Is there a problem with this?
Itai was complaining it's too large, and for cases in which we have longer sets of axioms, this becomes quite large.
Well, I don't think we should put the axioms there. I don't see any reason to do that. Or alternatively, similarly, for the theorem, that could be quite long too. I would imagine you would have an elided version of that, only to a certain length, and then with ...
Right.
That's how it's handled at the moment. But Itai had the rather nice suggestion that the axioms should sort of be compressed within the summary box and accessible with the plus.
No, well, that's fine.
Which is I haven't committed it yet because I'm still playing around with it, but that's what I've been working on.
Sounds highly sensible to me.
Mm-hmm.
Okay. Okay, so let's keep going back to this design stuff. So there's a detail of what colors are being used. Is that correct?
Mm-hmm. And I believe in one of the, I think it should have got sent along with the notebooks, I have two mock-ups going around larger views of this with the colors that I have specified in.
Okay, so this is this creature.
Mm-hmm. It's, I think if you zoom out, it'll give you a slightly more bird's eye view of it.
Okay, I think we already said that we wanted these dashes to be finer grained dashes, right? Isn't that correct?
I did not have them in my notes, but I will reflect the mock-up to do that.
Okay. And this is fine. I mean, there's some color palette here. Do we agree on what the logic of this color palette is? Why is this color palette the way it is? Why is hypothesis in green? Why are axioms in red, and so on?
I don't see any.
Okay, well, didn't we discuss that last time?
I don't.
Yes, but if I remember correctly, the conclusion from the meeting was that we should have, or at least one of the suggestions was that the nodes in the graph should be shaped rather than, or in addition to colored. I haven't heard back from Charles about the possibility of doing that.
Okay.
Perhaps in a first iteration, colors is enough.
It's fine, but we should be able to get who's project managing this?
Nobody is. I think Sushma at some point, but
Sushma is Sushma away right now?
Yes, she is.
Mm-hmm.
Okay, well, she's supposed to be project managing this, and we should make sure that we get that item actually done. Okay, so if we think that we've got, okay, last time we talked about, you're right, having shapes for these. Should we just get Charles right now and ask him whether that's possible? I thought last time he'd said that some simple shapes are possible. Isn't that correct?
That was my memory as well, yeah.
Okay, so we need to know what those shapes should be. Did we come up with a list of what those shapes should be?
Other than the axioms being sort of triangular arrow type things and the conclusion being a sort of tombstone marker, I don't think we came up with any, but I think that's sufficient if we keep everything else the same and just change the
I agree with you.
The shapes of those two.
Well, what about the hypotheses?
It'd be nice if the shape of the hypothesis is similar to the shape of the axioms.
I agree. Now, in terms of the colors, I just have no idea what this color scheme is supposed to be about.
Right now, it's completely arbitrary.
Okay,
it's just one that I chose.
I mean, it should be something that makes some sense.
Mm-hmm.
So, by the way, we've got a bunch of background noise here. So these are all the types: axiom, critical pair lemma, substitution lemma, hypothesis, conclusion. Is that correct?
Correct, yep.
Okay. So, if there is a flow from, how do we want to represent the sort of arbitrariness of the initial axioms and hypothesis? Could whoever is producing that background noise please try to figure that out and mute themselves? Okay. So, and I mean, I would have thought for these intermediate things, using yellow and orange is probably okay. I don't know why, but and having color values that are fairly similar for the substitution lemmas and the critical pair lemmas. Does that make sense?
I certainly think so, given that they are, in some sense, the least important things when you're first looking at the network.
Right. So they should be in some probably yellowish color. That's okay. So then I don't understand why axioms should be red and hypotheses should be green. That doesn't make any sense to me.
Now that I look a little bit closer to the semantics of that, I agree with that. I would want them much more of a similar color value because they are first order. Yes, I agree with that. They should be much more similar in values.
Okay, well, so what are we going to pick for the, what is the axiom color versus the conclusion color? Do we have any kind of, what would we do if we were representing something where there was a beginning, of a race and the end of a race? How would we color those two different things? If there is any kind of, analogy there.
I think the analogy would be...
Chris, I think there's something wrong with your audio.
Oh, I apologize. Let me see if I can fix that.
Hello? Okay, then we got a bunch of other stuff we have to cover here. So let's so we are also doing this documentation and it's knitting, is that correct? That's the other thing we're trying to do here. Did we finish on the guys? Are you still there?
Yep.
Did we finish on what the proof structure is supposed to look like? Yes?
The proof steps, you mean?
Yes.
Yeah, so there is now a more compact version. It looks a lot nicer.
Okay, do we have Chris back or not?
I think he's.
Hello?
Chris?
By the way, this bug that these things are staying blue even when they're defined is still with us. Do I need to send mail about it or can somebody else take care of this? I reported it like a week ago. Okay, why are we listening to typing in our ears?
Chris is back with us.
Okay. Chris, are you here?
Yes, hopefully my audio is better now.
It is better. Yes. Okay. So do you have an answer for what we were just discussing?
For the colors, for the colors?
Start and end, yes.
What
would be a natural way of coloring something which is the start of something versus something which is the end of something?
I think it makes sense to me to have something a little bit more akin to stopwise. I think at the start of the thing, it should be green. Terminal things should be red, and we do a orange and yellow blend for intermediate things to go through almost sort of like a racetrack style set of colors.
Interesting idea. With green at the end.
No, I think green to begin with. Red is our conclusion.
Okay. I'm just wondering whether I don't find anything particularly useful. Okay, fine. That sounds okay. I think it might not be wanting to be, I mean, maybe it's more of a teal color at the beginning, so it doesn't look like, or we can have the axioms in one color and the hypothesis in a different color.
Mm-hmm. I've got as part of another project, I've been working with Color Data 97 to have a universal scheme for alpha graphics. I can think of two nice sort of tealish greens that I can have.
Why don't you see if you can construct this, and in the next few minutes, let us know, and we'll go on with some other stuff, and then hopefully we'll do the whole thing in this meeting. Okay, so let's take a look at this. This is as we discussed and designed it last time, is that right?
I believe so.
Good. Okay. All right. So in the examples that we have here, okay, so then you've also got what is the way of getting, we're not calling it human readable, are we? Didn't we have a different?
Yeah, sorry. The version that you're using, because I was still working on a bunch of things, I haven't actually committed it to the X kernel yet. But in the version I'm currently working on, it's called Proof Notebook, which was one of the suggestions from the meeting.
Okay, fine. Is that reflected in the documentation?
Not yet, but it will be.
Okay. Well, this doesn't have any.
But
Okay, so
the
this
property should go in the other, in proof object.
In the proof object, yeah.
okay. Okay, can be reduced to true using the axioms, then find equational proof. Is that really the right way to say it? I mean, isn't it, this kind of denies undecidability, if I might say so. You see what I'm saying? I mean, does it guarantee to find it?
No, the use of otherwise is probably wrong.
Okay, so then
if it can be reduced to yield false, it will return a failure.
Find a proof of the equational logic theorem THM using the axioms. This, okay. If find equational proof succeeds in reducing theorem to true, it doesn't need to say that because it's obvious, then it returns a proof object, right? That
Right.
correct?
Mm-hmm.
Then if it succeeds in reducing the theorem to false, it returns a failure object, right?
Correct.
Succeeds in reducing okay. Okay, do we need to make a comment about the case where it can't do it?
That's commented upon later with the time constrained parameter because
Where is the time constraint parameter?
Option. It's in the option section.
But where is it in the documentation up here?
In the option section, I think.
But that's just an example. It needs to be actually.
Oh, right, sorry. Yep.
So what are the options for this function?
That's the only option.
Okay. Okay, that, by the way, is mistypeset. Somebody should fix it. The ... is not correct typesetting there. I don't want to fix that right now. Make sense, Jose?
Yes, we'll worry about that, yeah.
Sure.
Okay, this is also not correctly typeset, and the expo one should be a subscript, et cetera, right?
Yes, yes.
Really, this could have multiple theorems here and multiple, so this is not really, this is mistypeset too. So
I was using the example of reduce or full simplify where lists can be specified, but they're only given as one parameter.
Okay, what other functions should we reference here? Proof object reduce, what else should we reference?
Find instance.
Okay.
Yeah, I was thinking that ideally when we can show false, we would return some sort of counterexample, but unfortunately, Waldmeister is not giving it.
Okay. Just a second. Okay, Chris has some updated colors here. Let's try looking. Yeah, that's quite nice. It seems a little bit more logical. The only thing that bothers me a little bit about this is that yellow really does stand out, and I don't think is that what we want or not.
I would probably reverse them in that case. If
Well,
yellow.
no. We don't want to stand out either. These are very similar. We don't want the yellow to stand out more than the other things in here. I would make these color values, I would make that yellow thing darker so it doesn't pop out. Does that make sense?
Yes, indeed. I can do that.
Okay, great. And those lines look a lot better.
I think so as well.
Do you know what? Do you know the spec to give to Jonathan so he can put that into the graph code?
In Wolfram Language line styles, I'm unsure. I'll give him the Illustrator sort of reference specs and go from there.
Fine. Find equational proof has the following option. So this is now time constraint, default value infinity. How much time to allow in finding it in how much time to allow. So now what happens what does it do if it runs out of the time constraint?
It returns a failure object.
With some kind of specification that said it was a time constraint failure or what?
Yep. So there are two kinds of failure. It's either the theorem is false or it ran out of time.
Okay. If find equational proof exceeds the specified time constraint, it returns a failure object. Okay. Okay, let's go look at proof object then. We can make this an actual live page.
I'm thinking simplify has time constraint 300 seconds.
I think this should have infinity because simplify is used as part of other computations.
I see. Yeah, that's a good point.
By the way, the thing that this should reference first is full simplify before even reduce, right?
Yeah.
Is it correct for it to reference reduce?
I think so.
Some of the format of the sort of function is based on reduce.
Okay. So where in that list should we put find equational proof? Arguably at the end, it's really kind of a different thing.
Yeah.
Okay. Now, proof object.
Eventually, it will support other types of logic, but right now it's only equational logic. That's why we put it there.
Why aren't we just showing an opaque thing for the actual innards of the proof object? Analogous to what we do, let's say socket connection object as an obscure example, except I'm even wrong that it exists. Just something where we have an opaque object. Yeah, that's what we do. I don't think we should give the explicit contents here. I don't think it's particularly useful.
Okay.
what if so in the future, if we allow more general kinds of logics beyond equational, do we not want to have different summaries for
Of course,
proof objects for
of
each
course we
logic?
do, but we're not documenting what the innards of a proof object are. You just access, I mean, and by the way, this possible properties should include logic type.
Sorry, yes, it does. I haven't updated the documentation on that yet.
Okay, so shall I add that in here? So
Yeah, go for it.
Okay,
Those properties are from one build ago.
Okay, all right, okay. So let's go here. So let's say proof object and the obscure DocuTools mechanisms. Well, we'll show you this. Represents a proof object generated by find equational proof. Okay. Properties of an equational of a proof doesn't mean to be an equational logic proof. A proof can be obtained using possible properties include. Okay. Okay. So here we would want to say logic type. Is that right?
Proof logic.
What's that?
Proof logic, perhaps.
Better idea, yes.
Is it really a proof logic though? I mean, it's the logic is a feature of the theorem, the axioms, and the proof.
Okay, so what
I would argue the logic.
Or base logic?
Possibly, yeah.
Logic might be sort of a conclusion. I mean, what is it usually called? It's usually called, gosh, I should remember this. You know, when people say they're using ZFC or they're using some other, you know what I'm saying? They're using some foundation.
Yeah, foundation is the usual term, or axiomatic basis or something.
Basis logic. I mean, why don't we just call it axiomatic basis?
I'm not sure about that either.
Between the logic and the axiomatic basis.
Yeah, exactly. It's not quite
the same
Oh,
thing.
Michael, you're here. So what should we call it?
It depends what it refers to.
It has only one value right now, which is equational logic. But in the future, presumably, when we have other things, it will refer to something different.
I think logic is perfectly, because I mean the way these things are specified is you say sort of intuitionistic logic or equational logic or first order logic or whatever it is. I think logic is the right term.
So what are we going to call it? Equational logic like that, or just equational?
I would say equational logic. And then we could have, I don't know, modal logic or first order logic or whatever.
Okay. All right, proof object. What else are we going to have here? We might refer to layered graph plot. Is that relevant? Or layered, what is it called now? Just layered graph?
Still layered graph plot.
Is that worth referring to here?
Well, we're no longer using it, or at least I'm not in the version I'm currently working on.
Okay.
We're using the, whatever it is, graph layout layered or digraph layered.
Okay, should we refer to graph here under proof object? What else should we refer to under proof object?
Data set, possibly.
Yeah, seems obscure. What about the output of reduce, which is something a little bit like this? Michael, what do you think?
No strong opinion. I personally like reduce.
Just as a function, as your friend type thing.
Yeah, better than say full simplifier or something.
Yes.
You have more control over things.
Okay. All right. Okay. So we've got these. Okay. So we've got to knit these things, but more to the point, what happened, Jonathan, to your repository, data repository entry about theorems and proofs, axioms and theorems?
Right. So, I mean, we went through a few ideas at the last meeting. I think the one that we settled on, at least for the time being, if I remember correctly, was to have something like the old equational theory function, the experimental equational theory function that I made, which I can show off quickly now if you want.
Please, go ahead and do it. Yes.
Sure. Let me share the screen. So the essential idea was we'd have something like you'd be able to say equational theory, basic logic, and it would give you a list of axioms which you could then put into find equational proof using formal symbols. And then you'd have an association which would allow you to parameterize each of the operators. So if you want to specify the AND operator is given by A, you can do that, or you want to change the OR operator or something. And this just seemed to me to be a better and more flexible way of representing these axiom systems than having a data set with an association which you couldn't parameterize.
Right, but so where do these things come from? So these come from some resource, ultimately a repository of theories, but what about the theorems themselves?
We could have an association that contains the axiom system and a list of notable theorems.
Okay.
I suppose.
Notice that those have to be sort of in correspondence, because if you're changing the names of the operators, you better be able to change that in the theorems as well.
Right, exactly, yeah.
So what's our idea for that? I mean, we could say equational theory, basic logic, but then you're qualifying that basic logic thing, but then there are certain properties that you get. So for example, one possibility would be to say equational theory, and then that first argument is both basic logic and potentially a sort of qualifying association. And then the second argument is a property, and that property could be, the default property would be axioms.
Mm-hmm.
By the way, I mean, given a particular theory, an equational theory, does one consider an equational theory to be defined by its axioms, or can there be multiple axioms for a given theory?
Well, the theory typically is the whole set of all axioms and theorems. So
right, but for example, Huntington logic and basic logic, I mean, and then, you know, like my axiom system for Boolean algebra, does that get, is that its own?
Mm-hmm. You know? Yeah, so I'm using the same scheme that was used in NKS, where these are treated as separate axiomatic systems. Yes, they are equivalent, and find equational proof, if given enough time, can actually prove that they're equivalent. But I think it's useful to treat them as separate systems because the axioms they use are quite radically different.
But so when you say a theory, your concept is a theory is defined by its axioms, not defined by its, in a sense, I mean, ultimately, in some, I mean, of course, this is an awkward business because there might be two theories that are equivalent, but we don't know it.
Right, as was the case with Robin's logic for a long time and Boolean algebra.
But so there isn't one of these things that's called Boolean algebra.
Well, that is basic logic. Again, I'm using the naming convention from NKS.
Okay, well that's fine. But that is the okay. But basic logic is Boolean algebra with some particular axiom system.
Right.
Okay.
Well, with the standard Boolean algebra axioms.
There isn't a standard one. I mean, there's random ones in different books.
Okay.
I mean, you might, it probably claims in NKS that there is a sort of standard one, but it's kind of floppy.
Right. Whatever it is, that's the one I'm using.
Okay. This is pretty nice. Okay, so the question is then, if we do this, we could initially just define a bunch of built-in things in for equational theory, but then ultimately we would have somewhat obscurely a repository of theories. So Michael, how does this relate to, I mean, do we imagine, I mean, as we have other things in equational logic, would we have the same repository or different repositories? And how does that relate to the things that, you know, axiom systems that are available in, let's say, Lean and so on?
I do not know offhand. I mean, in Lean, there's basically only one axiom system really there. That's constructive logic. There's no choice in any form.
Okay.
Which basically supersedes this one. That's why there isn't a problem.
Okay.
But constructive logic is the equivalent of equational logic here. It's not so much the set of axioms.
Right. In a
Right.
Lean proof, you can still specify premises and things. That would be the equivalent.
The point in Lean is that they have a library, a large library that they use as basis. So, but they can still load various bits of them.
So I don't quite understand the analogy here. So, I mean, we believe that what we need here, okay, so there's an equational theory thing here, and that equational theory could be an equational theory associated with, let's say, you know, the I don't know, the join, append, prepend sort of fragment of symbolic transformations. So in other words, we could have a bunch of theorems that say, you know, the append and prepend commute with each other and things like this. Am I right? Which could be set up in this way. And that would then be, in this world, that would be equational theory of, you know, I don't know what we want to call it, you know, list operations or something. I don't know whether that's quite the right. And then now, by the way, what happens if we use actual Wolfram language ands and ors? Does it get all snarled up?
Yes, that will not work. I mean, the actual equational theory will work, but if we try to parse it into, I don't know, if we try and prove something from this.
Why won't that work?
There may be pre-evaluations that spoil.
Right.
Yeah.
But my question is, okay, so the point about equational proof is that we are assuming propertyless. We're assuming these binary operators have no properties. Whereas, and what you were doing when you said there are multiple axioms or multiple theorems, you're using the actual built-in AND operator that is somehow outside of the equational proof system. Is that correct?
Yes, right. So when you specify axioms or you specify theorems, the operators have to be symbols that we can then manipulate. They can't be predefinable from language functions.
We should say that in the documentation, by the way, and that should be in possible issues in the examples.
Sure.
Okay, are we going to try to introduce? I mean, without this equational theory thing, I have to say it's pretty hard to use this this find equational proof business. And I feel like, you know, this seems perfectly reasonable. Why don't we just introduce it? Is there any problem with that? I mean, can we get this in? You've already got a bunch of definitions here. Is that correct?
Well, I will be a bit concerned of having this symbol as system. We can have it in some experimental.
Well, I mean, it'll be an experimental system symbol. Why are you concerned?
Because it's the same thing that we did before, changing equational proof object to a proof object. We try to generalize. So here, eventually, we should have a more general object that takes a logic and then a name set of.
Why don't we call it axiomatic theory?
And is this a data function that will then interact with entities and things like that? Perhaps.
I would think so. I would think so. I would think that this is very much like, I mean, I would see it more like net model, right? With the neural nets where you can have, where it's basically just a shortcut for getting things from a repository. Am I making sense?
Does net model have this parameterization feature?
Which parameterization feature?
You know, the equivalent to being able to rewrite the and or operators.
No, I don't think so. Let me think.
I can't think of any nice way of getting this to query a repository and then parameterize some of the symbols. But maybe there is one.
Wait. So what you're saying is look, in the repository, and that's why not all repositories are the same. They require, in the repository, there will be a raw version of that first expression with default choices for the symbols. What are the default choices?
And or not.
Okay, and what are those? Are those symbols in the global context, or what?
No, they're strings.
Ugh.
At present.
Ugh.
I can't think of any better way to avoid
let's
generating
think about
symbols in global.
Michael, do you have an idea here? I mean, they could be entities, I suppose.
That's what you had suggested recently, which everybody has talked to so far thinks it's a pretty okay idea, but I wanted to have a LCC meeting about it.
Okay, well, let's summarize what the rough idea is.
The rough idea was that we would have entities for things that right now we like generically to be heads, and we inactivate these entities, and the inactivate entity typesets more or less like a symbol rather than the yellow box, so that it becomes nice and short readable.
But that's what we were talking about for like mathematical constants.
Exactly, functions mostly, because we want to use it heads.
Yeah, okay, fine.
Yeah.
Okay, but these ones are much more arbitrary. These ones just come with, these are just random binary operator, often interpreted as AND.
Yeah, but if it's random, it kind of cannot be an entity. Like an entity has a certain well-defined set of features that define it.
I understand that. So that's the point. I mean, that's the thing that is bizarre about axiomatic theories, is that, ultimately, in this was the kind of 100 years ago kind of notion, right? That these things are just, it's just a binary operator, it's just a unary operator, and that's all you have to say about it. The fact that we interpret it as and or is kind of a separate layer. So the question, but clearly for this, we need to name, this is a thing, this is a thing conventionally known as and, right? It is just a binary operator number 2 in this axiomatic system, but it is conventionally known as and we want to have this or that mapping. I mean, the fact is, look, if you look in one of the kind of 100 years ago books of mathematical logic, you will find it says, a theory is defined by certain operators, and these variables it probably doesn't talk about, although it will say, we have the following essentially dummy variables. Am I making sense?
Yep.
And so what that's basically saying is that sort of qualifying in a sense, there's a manifest that says, in this instance of this of this axiomatic theory, we are going to, as the binary operators, we're going to have things called A, B, and Q or something. And as the this, we're going to have it as that, and so on. So in a sense, what I would expect the original sort of object to have, a bunch of lists or associations that basically name, I mean, it's going to have a list of binary operators, a list of unary operators, a list of operator symbols, basically. As part of the original axiomatic theory, there will be a list of operator symbols. And then what you're doing is you're saying you can translate that list of operator symbols into a different list. Now, the question is, in the original list of operator symbols, arguably, in this notation, they should just be formal symbols. For example, we could have them be, I don't know, in the F range or something. We could have them be capital letter formal symbols. We have those, don't we?
Yep. I'm happy to do that.
I mean, Michael, what do you think about that?
It's going to be a
good,
lot.
not bad, I would think.
What's that?
Not good, not bad.
It's going to be so difficult to read.
Oh yeah, it's going to be absolutely horrendous to read. But the whole point is that if the raw form of these things is that, then what we can do is to map that into, for example, we can conventionally map it into something else.
Yes, but with the strings, it's very easy to map and into some other and, while remembering that capital F means and capital G.
Yeah, I understand that. I understand. But so the question is, what is the underlying representation for, and my point is that we should be using symbols, maybe. I mean, these are formal symbols that don't mean anything, but it could easily be that the initial, okay, the question is, what does it, when we're naming it and, what is that thing that's named and? Because in other cases, even the variables could have conventional names. For example, let's consider the identity in a group theory thing. How do you represent identity anyway?
Right now, I think it's with, I was using the letter E, and in this version, it doesn't, it's not represented at all.
But so what, wait a minute, what is that? That's like a constant thing, not a variable, right? That's
Right.
not a, okay, so then we have another, so what is the collection? And this is sort of standard mathematical logic. What is the collection of things? There's operators, there's dummy variables, and there's some kind of constants. Is that right?
Right. And the only difference between the dummy variables and the constants is that one set is quantified over and the other one isn't.
Okay. But so similarly then, what we're saying is that the identity element, right, just like the ands and ors and so on, the identity element is another thing that has a special interpretation and conventionally has a special name. So my claim is that there is a raw underlying representation that is completely obscure because it has completely okay, so here's the thing. You're prejudicing it by saying what's and what's or, because the fact is most of these axiom systems, you can switch those around, right? So, you know, and the very claim, I mean, take piano arithmetic, for example, you know, the fact that we write multiplication with a times sign in piano arithmetic is completely conclusory in the sense that the truth of the situation is the axioms of piano arithmetic don't at all imply that that binary operator is what we think of as multiplication. Because piano arithmetic also allows non-standard arithmetic, for which that quotes multiplication operator is some totally exotic thing that we might, you know, that there's no reason to think we should represent by a times sign or something. I mean, it isn't the multiplication that we think of. It isn't the multiplication that in Wolfram language would be represented by the function times.
Right, I understand, but is there not also an argument to be made that if you just return by default some list of formal symbols as your operators,
it's utterly obscure?
Yes,
it's utterly obscure.
Don't we want some kind of indication that says, you know, this isn't multiplication, but this is what is conventionally known as multiplication in the context of piano arithmetic or something like that?
Okay, so an alternative. Okay, so let me try another alternative. Sure. For the function symbols and the constants is we could have a wrapper and we could have the string inside. So we could have a wrapper that's called something like, I mean, just write it down, something like formal function of quotes and. Now, you know, the fact is we can typeset that in all kinds of different ways.
I like that. That's a good.
Well, Michael, what do you have? So then what we would do is we would
give a totally different meaning of formal than we use it for the formal symbols.
Why?
Because there we try to escape the context issue and the changing issues, which already somehow is solved with the pure string end.
But aren't you also, in the formal symbol, you're also saying that this is a symbol which can't be written to, which is the same as what we're saying with a formal function?
No, what I'm saying, that's the same already with the string end. You can't write to the formal,
right,
to the string end. So what you add is sugar.
Right, okay, yes.
Well, so wait a minute. So what are you saying? So you're saying this is a yet more formal, because it doesn't even mean, no, wait a minute. One other feature of a formal symbol is it has no well-defined meaning. It is a thing which can't have a value assigned to it. It doesn't have a meaning associated with it.
But there
And
are two
that's also-
different things, I feel like.
Okay, well, so explain. What would you call them? What would you call this one? I mean, we could be very obscure. We could call it axiomatic theory function. That seems extremely obscure. So
But-
let's write down the other case. So the other case is formal symbol.
Yeah, I was going to mention that because we shouldn't have to mention.
But I feel
No,
like
it's not and, it's identity.
but
That
I
would
like
be
it
identity.
conceptually. I feel like it's confusing because it isn't a symbol.
Formal constant.
But it works.
If you call something a symbol and you test if it's a symbol and says no, that's confusing.
Well, fair enough. And in some sense, the function name is also a symbol in the formal logic sense. But okay, so let's imagine it was these things. Then what would happen is, in the axiomatic theory, what we would have is a collection. So if we write down in the axiomatic theory, we would have an association, and the thing would have one of the pieces of the association will be quotes formal functions arrow, and then a list of formal functions, and then formal constants, and then we would have axioms, which are given in terms of those formal whatevers. And that's probably what we would have. And those axioms, okay, so then when we use the thing,
Axioms is returned by default.
that's correct. But axioms with the formal functions and formal constants, which would be typeset in a nice way, but underneath they would say formal function, blah, blah, blah. But then what we would do is we would allow you to say, let's say the formal functions were and or, we would allow you to say, somewhere we would allow you when you call axiomatic theory to say, so let's just write this down. Axiomatic theory, let's say group theory up. And then you'd say, possibly in that argument, yes. Then you would say something like multiplication arrow center dot, the symbol center dot. And, then you would say, comma, identity, quotes identity, arrow, whatever it is, E.
That's a little bit more or less like Lean would do it, yeah.
To do what? To
basically say, how do you want a certain operation to format?
Okay.
It does mean that we need to add, or maybe this isn't a problem, but wouldn't we need some kind of consistency check on the axiomatic theory that gets produced? Because now the formal functions, the formal constants, the axioms aren't independent.
Well, there's another problem, which is the theorems that you are. Okay, so the other question is, so then we could have notable theorems. And the issue there is in the axiomatic theory thing up there, we'd need to have some properties thing. So, I don't know whether we want to package that.
Where would they
that
come
won't work
from?
because-
That could only be for a finite amount of predefined stuff.
Yes, but I think what my point is that group theory with what we need is some kind of, we keep on needing this, something where, we're typically using rules to represent this group theory, arrow, whatever, to represent the subcasing of group theory with that multiplication operation and so on. So that then we could have the second argument of axiomatic theory be the property. And that second argument would be notable theorems, or it would be by default axioms.
But we could use a list in the first argument, which is list group theory, and then comma rules or association.
Yeah, it's probably reasonable. That's probably better. It's more consistent. It's it's an operator that we keep on needing. is a subcasing operator of some kind.
But why isn't this enough? And I mean, so we don't need the formal functions, etc. So axiomatic theory already would return with center dot, etc.
Well, but what if you don't give that? What if you don't give that second element there?
We could give instead multiplication, the string that we do have on the
I
left.
know, but we don't. I was trying to avoid doing that because I don't want to have strings as heads.
Yeah, but what I see is that now we are just wrapping the strings. Strings are still there. We are just wrapping them.
I know, but for some reason I think that's going to be better. I just think having strings as heads is just it's a path we've not gone down. And it seems weird to go down it for this, where after all, I mean, if we wrap it with formal function and formal constant, we get to typeset it in all kinds of ways and so on. I mean, we might even, truth is, if we typeset it as an infix operator, it would look a lot better, which we certainly could do.
But I feel like if we basically have this axiomatic theory and we have the first element of the first element, probably a finite list, I assume, and not freely choosable, because what would it do? Then I feel like we need a programmatic way to access the possible left-hand side of the second element.
Okay, fine. So the answer to that is it's axiomatic theory of group theory, that first thing, comma, and then it would be exactly the thing, formal functions, for instance. Right, so if you go, no, what are you doing? Leave that, Jonathan, leave that. We're all good there. On the line above, say comma quotes formal functions. Right, and that would then return.
Return to. How do I know in some bizarre theory that I don't know what can I or do I have to specify?
Right. Okay. Sorry, I understand. Yeah.
Yeah.
Okay, so let's call it formal parameters. We could have a combined thing called formal parameters, and that gives you that list of left-hand sides of keys that you have to give in that association.
Yeah, so multiplication, identity, and inverse.
Right. And now what we could do is we could say formal parameter, we could have another second element, which is called formal parameter rules. Okay. No, don't change that one. Copy it down. The formal parameter rules. And what that returns, just as a convenience, is that association saying multiplication, string multiplication, goes to formal function of quotes multiplication. So in other words, it gives you defaults there, right? So it's giving you the defaults, and the ones you want to change, you can change to whatever you want. You can either change them to other formal functions, or you can change them to, center dot or something.
Mm-hmm.
Now, ultimately, the way this would work, presumably, is that each one of these things would get its own, essentially, documentation page, because it would actually be in a repository. So the fact that these might be built in initially, might be a small number of built-in theories, ultimately there will be a repository that initially would contain probably 20 of these things. And then, in principle, people could add things to that repository. And in principle, somebody could add, just like, I've got that list in NKS of just random axiom systems, right? Somebody, it's sort of interesting. Somebody could add a random axiom system, but they've got to put a description in there. And it's like, this is random axiom system 123. We don't know what it's good for, is a somewhat unconvincing description.
This, of course, begs for extensions. Like, I have group theory and I want to add a second binary operation to it.
Great. Then that's fine. Then what you do, then there's no reason why you can't refer to the group theory in, when you build out another repository entry for another axiomatic theory, refer to group theory. Because it's already in the repository. And the repository has the feature that once it's in there, it's not coming out of there. So you can permanently refer to it. Now, the thing that is slightly bizarre and interesting is this point that, there's an infinite collection of possible axiomatic theories, only some subset, not well understood what it is, do we care about in mathematics. And that's sort of laid quite bare by saying there's this repository and you're just putting into it the interesting axiomatic theories, as opposed to the arbitrarily constructed ones. I mean, I think this is pretty reasonable. I don't know. Jose, Jonathan, Michael, comments? Is anybody, was James here also?
I think so.
If he's here.
Yes,
maybe,
yes, I'm here.
Have you been paying attention? And if so, do you have any comments on this?
I generally think it's a pretty good idea. And I am particularly interested to see how extensions might work.
All right.
I like the axiomatic theory part. I'm not so sure about the formal part. In particular, this distinction between functions and constants. I mean, can we have just a formal thing that?
A formal construct, we could call it.
We should probably discuss it with Rob, everything.
Right. I mean, I think there in Lean, they tend to refer to all of those as constants.
I see.
It's
I mean, it's unfortunately, it is similar to the things that we have. We have this notion of external objects for other purposes, like referring to random things in Modelica for system modeler. But I think that's a little different. I mean, this thing, look, this thing, I mean, it has 130 years or something of somewhat mottled history of what on earth are these things. Because, this is the horror of they have a name, but the name doesn't mean anything. It's a class of things which are, these are more formal. Well, I mean, they're not that unlike the symbols in our language, which also could mean anything.
yes, but our language is symbolic. So introducing something which is called symbolic or formal feels
Well,
strange.
it's more formal. I understand that. But in what sense? Okay, can we describe sort of philosophically, why is this more formal than what we already have? Or isn't it? In other words, what's the difference between the symbol F in our language and a formal construct? I think the answer is because these are dummy objects. The only thing that matters is that they are consistent. They're scoped effectively. The only thing that matters is that when you call it F, when you call the binary operator F in some theory, you better call the binary operator in the theorems you're trying to work on in that theory also F. But the actual name F never has significance. Whereas in our language, when you have a thing called foo or something, that actual, I guess the point is that in our language, that name foo is supposed to have, I mean, it can have a meaning attached to it. Yes, it can have an explicit meaning attached to it by being assigned values and so on. Whereas
Right.
in this setting, the thing is merely a placeholder because it can never have values associated with it.
Well, it has implicit constraints that are set by the axioms rather
Yes.
than an explicit value. I think that's the key difference.
I think
I
for me,
agree.
the main difference would be there is no notion of evaluation normally in the series.
Right.
Right. I mean, honestly, our symbols, insofar as we're a sort of pure functional language, obviously our symbols play the same role. They're merely, they could be, they're merely things holders of structure, not holders of, I mean, look, the question of how they hold meaning, one way to hold meaning is to have a value that is found by evaluation. The other way to hold meaning is by your relationship to other things, which is kind of what's happening here, is we're defining these constraints which define the relationship of different constructs. Well, we need a name for this. I mean, it's what should we start off calling it? I mean, the possible names are formal symbol, which seems kind of silly. formal constant, which seems, the other thing we could call it is, what about axiomatic constant? Or axiomatic symbol for that matter. But axiomatic constant seems better.
And why don't you like formal, just formal?
Because I'm worried about using that up here. I mean, maybe that's a future. I mean, this is, the thing is, okay, the question is, how much do we really believe in mathematical logic? In some sense, because this is, I mean, my own feeling is that there's some significant evolution that's happening. I mean, look, if you look at the history of this field, right, it was, people in the time of Frege and Peano and all those guys, were trying to abstract away from the particulars of, plus and times and all that kind of thing. They just said, let's put in these formal symbols of some kind. But somehow, I don't know, somehow with this rebirth of proof assistance and all that kind of thing, I kind of think we have not reached the end of kind of the ways things will be represented, in particular as we start getting programs represented in this formal way and so on. Did that make any sense? Probably not. I mean, my point is, okay, we are only in the very early stages of programs being represented formally. And I have no idea how we're going to take our language and start. I mean, so in other words, given our language, right, things like prepend and append are at some level symbols that are direct carriers of meaning.
Mm-hmm.
But they're also at some level things that could be the subject of theorems. Am I making sense?
Mm-hmm.
And so I don't quite understand the relationship between that. And I can imagine that we're going to want a version, just like we're playing around with it in activation and so on, as a way to be able to manipulate code. I think we're in the early phases. Okay, the difficulty is prepend and append are directly given meaning in our language, just like and or were conventionally given meaning in Boolean algebra, in logic, before people came along and said, no, let's abstract it away and just call them arbitrary binary operators. But we're still at the stage where we imagine that there is a ground truth meaning or something to things like prepend and append. And it feels like what we're doing here is we're trying to abstract away from the ground truth meaning. And I don't quite understand how that works for different. Did this make any sense? I mean, we've also obviously got and or in our language, but we have to abstract away from those because we're trying to work with them formally, and we don't want their traditional properties to be, to be in there.
Right.
As a temporary solution, we could have a context called formal, and we put all these symbols there temporarily until we find a better solution.
All which symbols?
And they are protected. All these symbols that are the default operators, constants.
Why would we want to do that? I mean, why not have a wrapper with strings? Because then it's much easier to deal with them in these associations where we can just, in a shorthand, we can just, like in that axiomatic theory thing, we're not saying formal blah, blah, blah of multiplication goes to this. We're just saying multiplication goes to that.
Yeah, it's because if we have to introduce a system symbol and we are not sure about the name, I was trying to find a temporary.
But no, I understand. I don't think, look, I think, what do you think about axiomatic constant? Or for that matter, axiomatic symbol? I mean, it gives some conceptual contextualization that this is about axiom systems. And I would argue, okay, so axiomatic symbol, for example, this would be a good question to ask Dana Scott. He might have an immediate and sensible answer. Or he might tell us that it's all unbelievably complicated and it's impossible, in which case we do whatever we thought we were going to do. Go ahead.
The symbol is being used in the context of an axiomatic theory, but the symbol itself is not axiomatic necessarily.
No, I understand that. It's an abuse in a sense. But what is the symbol? The symbol is in some sense It is what would usually be called formal. It is merely a placeholder. It is something that has a role in an axiomatic system. But I mean, in some sense, it is axiomatic because, okay, there's a view of the world which is in terms of axioms. There's one view of the world which is just there are numbers 1, 2, 3, and they have certain arithmetic properties and we can compute with them. There's another view of the world which just says, we don't even say what a number is. We just have this formal thing and it obeys certain axioms.
Right.
And what this is saying is, this is in the view of the world. Well, what is this? This is sort of an intermediate case because this is a view of the world where the structure is predefined, but the meaning is not. Right? So in the case of a number, in the case of a 1, 2, 3 type integer, both the structure and the meaning are predefined. We think there's a sort of ground truth meaning to them. In the case of axiom systems, we have the slightly hybrid case, which perhaps is not even right, that the structure is defined. Like we say, these are binary operators. I've never known of any axiom system that says is an operator. We don't say whether it's a binary operator, a ternary operator, or anything else.
Right.
I mean, axiom schemas go a little bit of the way towards this, but not all the way. But so then we're saying, so we're not just saying it's an operator. We're not going to say what kind of operator. We are choosing something definite with respect to structure. Because I think if we don't do that, we can say nothing basically.
Right.
So it's sort of a weird intermediate case, axiom systems. I hadn't really thought of it that way before, but they are a weird intermediate case. So the question is, what are those carriers of essentially axiomatic structure that are, how do we think about that?
I mean, if we go in this direction, shouldn't we then not kind of use model theory and related stuff?
And well, yes, these things we are defining effectively models. We're not quite all the way model.
Exactly.
Yeah, we're defining a model, but without any semantics.
Yes, it hasn't gotten all the way to model theory. It's kind of, I don't know whether the model theorists have a name for this stage, so to speak. But I mean, nobody talks about, to my knowledge, an axiom system without, without form, so to speak. The void axiom system, so to speak, without, people always say it has binary operators, et cetera, et cetera, et cetera. I mean, it's fairly similar to talking about, when you start talking about computation, and then pretty soon you're talking about Turing machines or cellular automata. They have structure. Humph. We need a name for this. I personally, I am not horrified by something like, either axiomatic symbol. I'm not horrified by the name axiomatic symbol, even though it's kind of weird. But this is a weird thing. I mean, this is a symbol whose character is defined merely by the constraints of axioms. We could call it axiom symbol.
The name variable is also used frequently in this context.
Except that they aren't variables. They're not. The whole point of them is they're not variable. I mean, the notion of, but the notion of the head of the operator, the thing that's going to represent a multiplication or an and or an or, that's not. What about axiom symbol?
It loses the immediate connection with axiomatic theory.
That's true. Okay, look, my current thinking is axiomatic symbol. It's a little weird. I mean, I don't know what would you think that meant? A symbol
that is defined axiomatically, which is
what it is.
Right. Yeah. Exactly.
On the other hand, when you hear axiomatic, you kind of think it's tethered somewhere, and this symbol is very untethered. In a sense, it doesn't have a meaning. It just has something which is defined by an axiom system. All right, look, I'm thinking axiomatic symbol, and I'm thinking we've got a proto design here, which is actually quite good, and that Jonathan should try and quickly, mock it up and put his data into it and see how it works.
Happy to do that.
Okay, we should wrap this meeting because we're super late.
Yeah.
Okay, and I should save back those pages. And we are not quite finished with the knitting for guide pages and so on. Okay, and I guess I'll see you guys in due course. And for anybody on the live stream, that's it for this episode.